Hello everyone. In this video clip today, I'm going to cover the very last section of our course. Yes. Section 9.5. It is about the binomial theorem. Okay. This is all about how to expand a binomial out. So let's start with this. You got say a plus b. Okay. Where a is any number, b is any number. A plus b raised to the first power. Well, start with 0 then. A plus b raised to 0 power. Assuming that not both a and b are not both 0, then it's equal to 1, right? Because we don't have 0 raised to 0. This is very trivial, by the way. Second case, a plus b raised to the first power. Of course, this is equal to a plus b. What if you got a plus b squared? And this just factor out 4 out, really. You got what? A squared plus ab plus b squared. Okay? Keep going. If you got a plus b cubed, this really means what? A plus b times a plus b and then times another a plus b. And if you factor everything out, you're going to have this. A cubed plus 3a squared b plus 3ab squared plus b cubed. Okay? How do I know this? Because I do this. A plus b times a plus b times a plus b, and then really all I have to do is 4. Okay? A times a times a times a times b, a times b times a times b times c, so forth and so on. Multiply them all out, and I have the answer. Okay? And then one more. A plus b raised to the 4th power is going to be equal to this. A to the 4 plus 4a cubed b plus 6a squared b squared plus 4a b cubed plus b to the 4th. Okay. And what we're going to learn today is what? Can we have a general formula for a plus b raised to the n? So I start this section inductively. I start with 0, then 1 square, and then 3rd power, 4th power. Try one more. Hopefully we can get the pattern out of it. How about a plus b to the 5th? It is, how do I know this? Just a times b, a plus b, I'm sorry, times a plus b times a plus b, like 5 times, and then I factor them all out. Okay, I 4. I got what? A to the 5th plus 5a to the 4b plus 10a cubed b squared plus 10a squared b cubed plus 5a b to the 4th and plus b to the 5th. Alright, so with that much information that you got on the board, is there any way you can figure out a plus b to the 6th? Alright, so what is the rules? What is the pattern? That was the question. Okay, there are 2 things that we got to pay attention in here. First of all, the terms a and b, right? You see the pattern in here. A to the 5th, and then what? A to the 4th b, a to the 3rd b squared, a squared b cubed, a b to the 4th, b to the 5th. What? The rule is what? Exponent of a keep going down. The exponent of b keep going up. A to the 5th, right? A to the 4th, a cubed, a squared, a, and then no a. B, the opposite. No b, then b squared, b cubed, b to the 4th, b to the 5th. And you see what all the equations are really symmetrical. See, right? 1, 5, 10, 10, 5, 1. You can read the other way around. 1, 5, 10, 10, 5, 1, right? Because A and B playing the same role in the game. And same thing with the others. You see the 4 right here. To the 4 cube square A and then no A. And B is the opposite, right? No B, B square, B cube, and B to the 4. Okay? That was the first part, the term. A and B. Follow that rules. And then the numbers, they call the coefficients. What about the rules for the coefficients? Let me introduce to you guys something called Pascal triangle. Okay. Hopefully I have enough space right here to write. Pascal triangle. So for the first one I got 1. All right. And then for the second equation right here I got 1a and 1b. I'm just talking about the coefficient of numbers. All right. 1, 1. And then for the square thing, I got what? 1a squared, which is 2ab. Oh, I messed up a little. Okay? 1, 2, 1. 1, 2, 1. Okay? And then for the 3, I got what? 1, 3, 3, 1. 1, 3, 3, 1. And to the 4th, I got 1, 4, 6, 4, 1. For the 5th, I got 1, 5, 10, 10, 5, 1. And figure out the rule right here. If you want to figure out the next line, you're going to use the upper line, the line above it. So it's 1 right here, 6 right here. All right, you see what? 1 plus 5 equals to 6. And then 5 plus 10 is 15, you see? And then 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. And then 1 plus nothing is just 1. It's true for any line that you see above. Okay, so I know that for the 6th exponent is going to be a to the 6th plus 6a to the 5th b plus 15 a to the 4th b squared plus 20 a cubed b cubed plus 15 a squared b to the 4th plus 6a b to the 5th and then plus b to the 6th. Okay? And if you know the pattern already, you can figure out a plus b to the 7. Let's do one more. A plus b to the 7. Alright? So what? The 7 is going to be 1, 7, 6 plus 15 is 21. 15 plus 20 is 35. 35, 21, 7, 1. So it's going to be a to the 7 plus 7, a to the 6b plus 21, a to the 5th b squared plus 35, a to the 4th b cubed plus 35, another 35, 35 a cubed b to the 4th plus 21 a squared b to the 5th plus 21 to 7 a b to the 6th and then plus b to the 7. Okay, so you guys see the first couple terms, couple equations for the binomial theorem, but I haven't shown you the general rules yet for a plus b to the n. For first couple terms with small exponent like 1, 2, 3, 4, 5, 6, something like this, you can use something called the Pascal's triangle. Right? The triangle tells you the coefficient, and the term a and b are going to follow the rules. What exponent of a keep going down, exponent of b keep going up, and you fulfill with the coefficient, the numbers. Then you have the expansion of a binomial. Okay? But we're going to be better than this. We don't stop at a couple of small exponents. We can have the formula or the theorem for a plus b raised to the n in general. Okay. So our goal today is to show you guys this. A plus b to the n, where n is any natural number, carrying number, like 1, 2, 3. Okay, any number is what? So in general, according to our formula we learned, for the small exponent 1 to 7 that we have right here, it's going to be this way, a plus b to the n, right? So the first term is going to be a to the n and plus some coefficient, I'll show you later. Then the second term is going to be a to the n minus 1b plus the next term is going to be some number in here, I don't know yet. And then what? A n to the a to the n minus 2 times b squared. You see what? Exponent of a keep going down from n minus 1, n minus 2, plus exponent of b keep going up, no b, 1b, b squared, all the way to the n is going to be b to the n, last term. Okay? And the term right before this is going to be b to the n minus 1 and times a with some coefficient in front. And the term right before this is going to be b to the n minus 2 times a squared with the coefficient in front. Alright? So in general, the binomial for exponent n is going to be the sum of that n plus 1 terms that way. Question is, how do we figure out the coefficient in general? in order to get there, I'm going to show you something called combination. If anyone have taken something called the discrete mathematics, it's about counting. Say, there are many ways to denote combinations. The C, like N choose R, or C N comma R, or R N right here in parentheses. This notation of something called N choose R. What is it about? Say you have, let me see, 4 markers. You guys see 4 markers, 4 different colors. And say I want to choose 2 markers out of 4, regardless of the order. How many ways do I have to choose 4 markers out of, 2 markers out of 4? Let's count. It's symbols of count. I have green and red one way, green and blue second way, green and black 3, and red and blue, red and black 4, 5, and then blue and black 6 ways. Okay, so you can see this. 4C2 means what? We've got 4 items. You choose 2 items. The combination is equal to 6. Okay, or in our book they're going to denote this way. Say what? 4 choose 2. Choose 2 out of 4 is equal to 6. And what is the formula for this? Now to get the formula in general, you recall something back that we learned. I introduced you previously called the factorial. So the general formula is this: NCR. Or let me use our book notation. Is RN right here. I think it's NR. Let me double check on it. Oh, NR. I wrote it backward. N choose R. Okay. So this is 4 choose 2. I wrote it backward. Sorry guys. So this is N up here, R down here. N item choose R item is equal to N factorial divided by R factorial times N minus R factorial. And recall 5 factorial means 1 times 2 times 3 times 4 times 5. Okay. So let's check it out. It's really true. Try a couple examples for the combination. Say 4 choose 1. I got 4 markers, 4 items. Choose 1 items. How many ways? 4 ways, right? This is what? 4 factorial divided by 1 factorial times 4 minus 1 factorial. So what? 1 times 2 times 3 times 4 on the top. This is 1 factorial is 1. Alright? This is 4 minus 1 is 3. 3 factorial is 1 times 2 times 3. Let's cancel out 4 ways. Okay? How about 4 choose 2? Is what? 4 factorial divided by 2 factorial times 4 minus 2 factorial, which is 1 times 2 times 3 times 4 over 1 times 2, or 2 factorial. And then this is 4 minus 2 is another 2 factorial, another 1 times 2. So 2 times 2 is 4. Let's cancel out. It's equal to 6. Really 6 ways. Okay? Let me talk about the combination a little bit more. We go back to our example. 4 markers. We have 4 ways to choose 1 marker. Right? Either this, or that. 4 ways to choose 1 marker. What about 4 choose 3? How many ways do we have to choose 3 markers out of 4? And I claim it's exactly the same as choosing 1. Why? You choose 3. This 3 marker is the same thing as choose the red marker. Okay? So 4 choose 1 is the same thing as 4 choose 3. It's still equal to 4 ways. So how many ways do we have to choose all 4 markers out of 4? Of course, 1 way, choose all. So how many ways do you have to not to choose any markers? 1 way, not to choose anything. That's the only way. Okay, so 4 choose 0 is the same thing as 4 choose 4 equal to 1. Okay, that is pretty much what we need for a combination in order to solve our binomial theorem. Okay, let's go back to our binomial theorem. And I claim that the binomial theorem say this. This is, I should be some room here. This is n choose 0. This is n choose 1, n choose 2, all the way. This is n choose n minus 2, n choose n minus 1, and this is n choose n. Alright? N choose 0, n choose 1, n choose 2, n choose 3, n choose 4. Okay? So, question is, how does it work that way? Let me try to explain it to you using a small exponent. Say I got a plus b raised to the 4th exponent. Okay? And what does it mean by this? It really means a plus b times a plus b times a plus b times a plus b, 4 times total. Okay? And you gotta factor out, FOIL everything out, and you have the terms, right? So you should, if you take a times a times a times a, you should have a to the 4th, right? You should a times a times a, then times b, you got a cubed b. And then a times b times b, you should have a squared b squared. And similarly, you got a b cubed, and then you have a to the 4th. That's what we have. Okay. Now, question. How many ways do we have for a to the 4th? Say I have 4 spots right here, right? I only have one choice of having a to the 4th. I've got to get an a from here, times an a from here, times an a from here, times an a from here. Okay? So, one choice. 4 choose 4 for a, or 4 choose 0 for b, because I didn't choose any b. Okay, so really 1. This is 4 choose 0. Let me use the book notation. 4 choose 0 equal to 1 way. Alright, for a cubed b. Alright, how many ways do I have to choose letter a in here, or how many ways do I have to choose a b? How many ways you choose a is the same thing as how many ways you choose a b, okay? Say I have to choose 3 a's and 1 b. I can have what? A, B. Alright, so out of the 4 markers right here, choose 3. Or out of 4 markers, choose 1. It's the same thing. Okay, or I can do what? A, B, A. You see? Or what? A, B, A, okay, or B, A, so total of 4 ways. This is really 4 choose 3, or 4 choose 1. So this is 4 choose 4, same thing as 4 choose 0, 4 choose 1, or 4 choose 3. Same thing, see? 4A choose 3 A's, or 4B choose 1B. This one is 4A choose 4 A's, or 4B choose no B. It's the same thing. And same thing here, this is 4 choose 2, this is 4 choose 1, or 4 choose 3. And this is 4 choose 4. And in order to organize them in the increasing order, we're gonna use this 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose, this is b to the 4. Choose 4. You can write the other way around, 4 choose 4, 4 choose 3, 4 choose 2, 4 choose 1, and 4 choose 0. It's the same thing. Okay? And that's explain how or why we have the general formulas right here for n terms. Alright? So in short, we're going to use the summation notation, the sigma notation, to write. This is what? The sum. Okay? And a raised to some power, b raised to some power. And then I here, I run from 0. I is the exponent, right? 0, 1, 2, 3, so I run from 0. I run all the way to n, run from 0 to n. And the exponent when I equal to 0, a is to the n, b 0, right? I here 0, then 1, 2, so really b to the I, right? You see? I equal to 0, b to the 0, I equal to 1, b to the 1, I square, b square. And look at the exponent. The sum of 2 exponents is always equal to n. So if b is I, exponent of a would be n minus I. Okay? And the combination is n choose I. And this sigma means the sum. You add them all up. Okay? And that means what? N choose 0, a to the n, b to the 0 is the first term. And then n choose 1, a to the n minus 1b, n choose 2, a to the n minus 2b squared, so forth. And the last term is going to be n choose n, a to the n minus n, which is a to the 0, which is 1, and then b to the n, which is the last term. Okay? And this is really the binomial theorem. That was the first part for this section 9.5. The second part, I'm going to show you a couple examples. See what kind or what types of exercises you're going to see in your homework, in your assignments in general. So the first type of homework is they're going to give you a binomial with small exponent and ask you to expand the whole thing.